Here, the Hojjat. I hand the floor to you.
Thank you, Dr. Chanarang, and good to meet you all. Sometimes in Zoom, it's not as easy as in person. Thank you for giving me your time. Uh, Let me see if is the audio okay?
Perfect Hojjat. Really good.
Yes.
Okay, perfect. Okay. So, you know what I want to talk to you about, as Dr. Chanarok said, it's about this, we are at the frontier of ethics on some of these key technologies. And my background has been in semiconductors and systems. And what I like to do, it give you a view on the ethics from disruptive technologies and how to look at these technologies from that angle. And I hope you find it useful. Um, so what I've done is uh, divided the talk into four sections. One is really to understand ethic. I hope to convince you that to understand ethics clearly, you have to have deep understanding of disruptive technologies. So my first talk, I would just walk you through what my career had been in semiconductor and give you some examples there. Then, look at from Midas touch and why these issues are a lot more serious than before because of disruptive technologies. Then, maybe look at few examples and hopefully give you a different view that you may not have heard about, and then end it with another way to look at ethics. That's the talk. So let's just start with this. Um, if you listen to my last year talk, what I tried to do is change it. This chart is the same, and the way I want to show disruptive technologies is really through three key pieces. One is every technology you look at is always a tool and a weapon. And this hasn't changed, from if you go back to the invention of even knife, it goes to the same. It's a tool and weapon. And the other attribute of technology is always is like a creative destruction. What it does, it you get a new technology, you change an old way of doing things, and it completely destroys it. So it's new technologies, they have this power of creative destruction. Basically, a new way you do things and things change. Now, if you look at technologies as tools and weapons and creative destruction, you also want to look at what is the rate of growth of that technology. In that sense, we always say, is it exponential or not? So through the example, you would see why AI and robotics are a lot more complex than maybe previous type of disruptive technologies. And then, in terms of exponentials, uh, we it looks very simple, and all of us have done math, and this is a very basic math that is done at high school level. So if you look at these, one point which comes on is why we are not aware of exponentials. And why do we see everything linearly? And again, it goes back to the way we look at technology. We compare it to most recent cases. We never go back 10 years and do a comparative to see what has changed. For example, some of you may remember when iPhone 1 came, it was a small device. And to look at it today, you may start laughing that why people waited hours in line to get this technology. Where you look at iPhone 16, you always compare it to iPhone 15. When you compare it to iPhone 15, not much has changed. You never see exponentials. But if you look at iPhone 1 versus iPhone 16, you really see exponentials. So my career has been, in semiconductors, and even then it was not clear I was riding an exponential curve in semiconductor for exactly the same reason. Is because we always compare it to the most recent things. We never go back in time and look at things. So I just want to show you, for some of you may not be familiar with semiconductor technology. Transistor revolution, we call it GPT. In this case, GPT means general purpose technology, like electricity, like, things will completely change the way we do things. And again, some of you may know the chip on the right. It's a latest invention by NVIDIA, and the chip name is Blackwell. It's a GPU, and as you can see, it's like, a lot of transistors in it. Let me see if I can get the cursor. Just give me 1 second. Hmm. Okay. Is the cursor shows on the screen?
Yes, yes, yes.
Okay. So as you can see, this chip, compared to, I just kept like 50 plus years here. So the first chip, 1971, 2000 transistors. And then now you're talking about 200 billion. And if you just do the math, every 2 years doubling, you take 2 to the 27. So let's say roughly 54 years and a factor of 134 million compared to a factor of 50. And I would argue that everything that you would use today is because of this transistor revolution. Like for example, this call is possible because of transistor revolution. The routers in the network, the whole internet, the screen technology, everything we are doing right now is because of this transistor revolution. So it's called GPT for that reason, because it's general purpose and it has penetrated the entire ecosystem. Now, if you look at this chip, the reason they can make it is because they can create a digital version of it first in simulation, and NVIDIA spends millions of dollars to generate a digital version of this. And these memory chips are called HBM. In this case, I think they are from SK Hynix in South Korea. And the fabrication of these dies is in TSMC in Taiwan. It's all designed in NVIDIA. NVIDIA, as you guys know, is San Jose, but it's really a global company. Each piece is designed in some location, mostly in San Jose. And it's packaged in Taiwan. It puts the substrate and all that. So the way this chip is successful is that there is a digital twin version that simulates what we would see when they get this chip to the market. And if you look at that, this has been like this for chip design for the last 25 years. Nothing has changed. So the complexities have gone on, but the process of designing this chip is very similar. So what happens in this case, there is a digital twin, and that digital twin is simulated. And once they are fabricated, they would compare the results. And if there is any anomalies, they fix it and they tape out another chip. These chips cost like, by the time they are done, like 500 million or more in these platforms. And that's from concept to production. So they're very expensive. A lot of tools, a lot of people, lots of ecosystem is involved. And the reason I'm mentioning it is because some of the ethical issues we get there later on uses these concepts of digital twins. And somehow I wanted to bring your attention that where these things are possibly coming from, in terms of the existing infrastructure. So chips are everywhere, as you guys have noticed. For example, President Trump, President Xi, there's all these discussions about chips. And and transistors, are really the foundational blocks. These chips are compute. So if you look at it, basically right now, if you look at all the tension that is caused in Taiwan, one of the key reasons is this company called TSMC. And that company is one of the number one manufacturer of these fine nodes. And if you look at that company, there is a dependency to Denmark for ASML and then to design. So it's really a global supply chain. It's not just one place. But again, as you can see, there's a lot of attention is given to this because under the hood of AI is these chips that make it possible. Um, then, the way to look at it, what is happening is to look at hyperscalers. Hyperscalers are companies like Amazon, Baidu, Google, and so on. They are massive. They've built these massive compute platforms. These platforms, if the way to think about it is compute, massive compute, storage, and networks, very sophisticated software. So sometimes they are simplified as deep learning software, but if you dig in, there is multiple layers of software, and some of it is deep learning or machine learning, and then there is like massive infrastructure built around it. And then there is these massive companies, as you guys, again, well aware, for example, ByteDance, which is behind TikTok, Baidu in China, Alibaba that everybody knows, and then obviously Microsoft, and AWS is really Amazon Web Services, which was number one in terms of market share. Then on top of this compute, you're seeing these massive applications. And these applications are really creating billions of revenue for each one. So if you look at it right now, the race between China and US is really how to build these massive computer systems at a scale, and then who can race to achieve or to gain more intelligent machines. That's what the race is about. And we are at the early innings. So if you recall the Moore's Law chart, we are in the 2000 transistor type of environment right now. That's where we are today. And imagine like if this thing goes exponential, what happens? To give you one example, I mean, even if you talk to anybody, sorry, talking to anybody, you can say ChatGPT and they know what it is. So if you look at ChatGPT, the first introduction date was November 2022. So when you look at exponentials, see, November 2022, if you went one day before, you didn't know anybody knows ChatGPT. Right now, it's part of everybody's lingo. What it does, how much they used it, and it's just starting. So that's a clear example of exponential growth technology. Now, you may look and say, okay, where ChatGPT came from, where was this Sputnik moment for China to realize how important ChatGPT is? Again, it goes back to DeepMind, and DeepMind right now is a division of Google. And if you look at it, for example, Google acquired this company for 500 million. Today, if they stayed independent, they would be easily $400 billion company. Just again, looking at the exponential in terms of market cap. See, 500 million to something like 500 billion today. That would be their market cap. So this small engineering team in UK, and I'm sure you're very familiar with this story, AlphaGo with Lee Sedol, and then in China, they beat the champion of Go. And really, it was everybody's wake-up call on what the machines can do and what are these capabilities of these systems. Now, again, if you go one layer down, what you will see in these systems is, I would say, sophisticated software layers. That's the way I look at it. It's not just deep learning, it's a lot of software layers on top of each other. And what basically it is, with data, with the cloud means compute, you can do a lot of things. For example, all of you may know to play chess, but I don't think any of you believe that you can beat any chess program on a laptop, right, today. And imagine like if it's running on a cloud, because the way it's organized, if the problem is bounded, it's very hard to beat it because of the compute power and the training which goes into it versus a human being. The other wake-up call is really if this date shows on the screen, we are talking about last year, Nobel Prize was in chemistry, which is unheard of, with two AI engineers, given to two AI engineers. See, this is never happened. If you look at it, two AI engineers winning Nobel Prize on chemistry because of AlphaFold. Again, I'm sure you guys have read about it, you know about it. So that's what we see, what the compute can do at this scale. Now, you may say, okay, where are we today? The way we look at it is obviously US is ahead, but China is catching up very fast. And then the rest of the countries, if you look at it in terms of capabilities. Again, you guys have heard DeepSeek. I surprised everybody. Now, one other way to look at it is look at downloads from app stores. You would see that TikTok is from China, Timo, and a number of other ones. If you go down the list, there's a lot of things. So I would say, if you look at this race, you clearly see US-China competition on compute, and compute is sophisticated software running on it, and then looking for intelligence. And that's where the trend is. No slowing down because there is absolutely no trust between any parties. Nobody would slow down. Again, if you guys recall, there was even Elon Musk and a number of people signed petition about the slowing down the AI development. Nothing happened. It's just going as fast as it can because no country would trust another country to slow down. So US is merging ahead, China is super speed, and every other country that matters is doing the same. So I hope I convinced you that, the semiconductor are becoming a big piece because you put compute infrastructure give you sophisticated software, and then you take it from there. Now, the other thing, if you look at it now from an ethical angle, um, first time I saw this example, I thought it's very naive, but the more I thought about it, I thought, wow, this is just a beautiful way of illustrating things. That as human beings, we make these wishes that we want something, and then it's very hard to know first order, second order, third order impact of these wishes. And then once they open up, then we see, wow, I didn't want this, I didn't want that. So the Midas story, simple story about he wished that he can touch things for gold because he wanted to be rich. And then, tried to eat, couldn't, tried to hug his daughter, couldn't. And then they said that these are not the stuff I want. I just wanted to touch some things to become gold. And for example, as an analogy, if you look at social media wasn't like to bring mental health issues, but first was very simple wish that we're going to be connected, we're going to share this amazing news together, we're going to be together, we're going to share everything, and everything is going to be amazing. And what happened was all the second, third order effect of it. And I'll walk you through one. One is the flight, so we made a wish for flying. Obviously, you look at the emerging technology, and I would say AI is where this thing is today. So AI today is compared to this. It has this capability, as you can see, 120 feet in 12 seconds. You look at this technology and you say, wow, this is not usable. There's lots of issues. There is, for example, in AI, there is hallucinations and all that. How can you use it? Then you speed ahead, it becomes tools and weapons. And then you see in the tool side, you say, wow, amazing, we can connect together and all that, and obviously sophisticated weapon. And you zoom ahead, then you say, wow, it's delivery, it's robots doing, drones doing all sort of jobs, job displacement. But then, maybe a third or fourth order effect is COVID-19. Interconnectivity in the globe meant that any infectious diseases can propagate very fast. Because, imagine like if we didn't have airlines and transportation, you would not even hear what happened in Wuhan if it started there. So these are all the effects that you can predict once you look at the technology at the beginning. Another example, this is very well documented. Obviously, you are riding a taxi, 2007, the radio says something about Moore's law. You are just paying no attention. Uh, the radio says, oh, Steve Jobs introduced this piece, iPhone 1. You don't care. And then 4 years later, two founders that were looking for a limo in Paris come up with this idea of Uber. Uber starts, Uber goes to delivery. It's like, wow, delivery. Now what happens? They learn all the data. What happens? Cloud kitchens show up. And then Waymo, Uber, if you guys have been in San Francisco, you can see no driver. You can get in with your app. You just jump in and jump out. Very safe driving. I have ridden them several times. It's just like unbelievable safe. App comes in, you just jump in, jump out. It's just weird at the beginning, but then you get used to it. Now imagine all the data they own, and then suddenly becomes a dark kitchen because it's robots in the kitchen. It's not Italian restaurant. It's not French restaurant. It's any restaurants. And you order, everything is robotics. So then suddenly you look at this wish that I hope I know when a cab shows up, and then suddenly you see a complete displacement of any restaurant, for example, for delivery. So again, first, second, third order impact. The area that, another example is, again, extremely well documented trolley problem, before was a philosophical discussion, that what is the moral of like seeing that the train is going this direction, and if you just move the lever, it goes this direction, would you make that call? So it's very well documented. I'm sure you guys have read it several times. And then you get to a point, and then you say, oh, would I make this call if this was my own kid, if this, if that, if this? There's a lot of cases that can create moral issues. Then you come to this type and you say, okay, what is the algorithmic choices are made? Who decided those? Who's responsible for it? If a deer suddenly shows up on this highway, what's going to happen? What sort of decision this car is going to make? And is your safety should be the first to protect? Is an option you can buy on the car with that, or all sort of things. As you can see, a new technology comes in and then creates a lot of things about what are the stuff that you can do about it. Now, you go to another one, you look at this biotech and human enhancement. And again, it's very basic research will give you all this data. It says, well, gene editing should be allowed designer babies. Where is the limit? So if it's a disease, nobody has a dispute. So yeah, let's do it. But then what about enhancement of blonde? And for example, in my case, never losing your hair. Some of these, they become questionable. You say, well, why not? It's so easy. I just don't want to lose my hair to the age of 100 and look that way. So then designer babies, who makes those decisions? Then you look at brain enhancement, all this stuff doing, what can you connect? And then cloning, what's allowed, what's not? What can we do? So then, you look at this and you look at surveillance mechanism and you say, I don't want Big Brother watching us because I just don't think that's ethical. So I want my privacy is very important to me and I don't want to violate it. But in this case, you may say, actually, I like it because I don't want some, let's say, person who suddenly starts playing with biotech in their basement and causes a massive havoc in the world. So I want actually surveillance. I want to trust my government because I don't want this thing to happen. Because advanced technology got so powerful that, as an analogy, for example, today, nobody can build an atomic bomb in their basement. But let's say you get to 5 years, 10 years, that you can do these disruptive technologies in your basement. Then what do you need? Maybe in that case, you want surveillance. So then you look at the technology, you look at the side effect of some surveillance, and you may say, oh, no, I don't want that. But then you look at it and say, no, 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 I really like it. Let's have it. So is China ahead in that case? Ahead of us. We're just not seeing it yet. Then, the only thing which always comes back, it says, why don't we slow it down? Why don't we slow this down? Why don't we slow this down? And the area that happens, and I think the only thing I can see is we are the only animal which is aware of our mortality. And we're very aware of it. And that's what we don't want. So I think it's very hard to stop progress on disruptive technologies. And disruptive technologies inherently create ethical issues. And the ethical issues then drive new technologies to combat them. For example, on privacy, if you care a lot about privacy, Big Brother watching, encryption comes in as a technology, or crypto comes as a new technology. But crypto as a new technology comes in, and money laundering comes out, for, drug dealers. So it's just like continuously in this circle of disruptive technologies creating these ethical issues driving some new technology development, and this circle continues. So this is a new one. I think if you recall, I talked about the simulations that we have done. And I gave one of my pictures to ChatGPT. I said, can you create a robot version of me? And as you can see, if you recall the Blackwell chip that I showed you, today we have a digital twin version of that 200 billion transistors. We do software development on it and all that. So this is the new wave, I would say, in the next few years. You can train these systems to be just like us, because every time you use ChatGPT, again, if you look at all of them, they are putting infinite memory on there. So soon they would be very, very aware of your personality, preferences, and all that. So what happens is that then, if you recall, if you have self-driving cars, one idea was that if they are fully autonomous, you can send them to work. You come home, the theory is you come home and your car goes to work. You're sleeping and it comes back and it says, wow, I made $500 last night. So then imagine the DigiMe not sleeping, it's to start working. And maybe DigiMe shows up and does this presentation. First of all, would be a lot better. Maybe no accent, that's one. Two, it would research all of you and find out any type of strengths, what areas you guys enjoy, what are your strengths in terms of education, knowledge, work, and tune every example a way that it's much more understandable. So then which one would show up? There is a very good case study. There is a philosopher, Dan Dennett. Unfortunately, he passed away last year. Before that, he agreed with a professor, which was an expert in training ChatGPT 3.5. So that ChatGPT wasn't as good as what we have today. What he did, he used all the books of Dan, every article, every YouTube video, and trained the model. And what they did, they basically went to the people who knew Dan very well, colleagues. And they basically said, if you ask a question from Dan, they would feed it to DigiDan, and Dan get two responses and let the colleague or audience decide which one is the real person. Believe it or not, the people who knew him very well, they chose DigiDan as the person. So you may have already studied that paper. Again, it goes back to what are the solutions for this? And I don't think there is an easy answer. I know you guys are studying this. Love to hear your thoughts after. I don't see an answer. but love to listen your opinion. I think it's a complex things we are doing. My last chart, the other thing, I think if you look at ethics and us, and maybe why it shows up so frequently, especially with disruptive technology, I found the answers are all in the actually good songs. One of them is from U2, is I still haven't found what I'm looking for. I think this is the sense in human beings. We have this sense that we always want whatever we get is not enough. We are searching for something more. And that usually creates more digital technologies, more disruptive technologies, and we go through this ethical loop. The other reason is change. We always want change. Anytime we change, it does the same. Um, the third, I would say, our imagination, because it's so useful, it works very well. And we always imagine things that don't exist and we want to implement them. So that's the other part. Uh, Mr. Roboto really is about the dark side of what happens if we become extremely virtual and become dominated by these machines. And then the last one is from Queen. I think there is a sense in us that we want it all, we want it now. So the patience is not there. Before, philosophical discussions were in the hand of philosophers. So it was very slow thinking, very not impactful. Trolley problem was done by studying philosophy. Now is in the hand of engineers. And I can tell you as an engineer, no patience. We want to implement it, get it done. If you guys look at Elon Musk, is a classic example. And thank you very much. If you have a chance, let's connect with LinkedIn, and really appreciate your time for listening to me. Love to hear your thoughts, and then have a discussion on this. Thank
Thank
you.
you. Thank you so much, Hojjat. You did again. Wonderful, amazing lecture. Thank you for sharing knowledge. So right now, just jump into the questions. So I say, Jay, go first. Just a moment. Let's see. Let me open the chat and
I think May was before me.
okay, May. Okay, May, go ahead.
No problem. All right. Thank you so much. This was a really nice lecture. I mean, I wanted to just comment on when you say now, I absolutely relate to it, how we're impatient and we're leading the changes, but is it really people mass or is it government? Because even research and everything is really funded or initiated by the governments and like private corporations. So is it really that we are doing that or more corporation and private and government interest, which you mentioned at the beginning of the lecture, it's mostly them leading that. I'd love to hear your thought on it.
Yeah, thank you, May. Definitely, I would say it's us as human beings, Um, and I think our incentives are not aligned with what we really want. Like, for example, if you look at any corporation is judged by Wall Street. Wall Street is basically two metrics: revenue growth and profit growth. So everything is judged based on those. So when you look at their action, usually is dominated by how they are judged. So for example, Meta or Facebook Meta is only judged on revenue. They don't really say what good things you have done for the society. And one of the stories about few weeks ago came out that some of the algorithms, uh, the details of it was that if a younger around 12 years old post a selfie on Instagram and removes it after 2 hours, the algorithm just goes heavily after cosmetic products after that person. So if you look at our incentives are not aligned, and I think awareness of mortality is the other reason. We're always looking for what is out there, and I can't, from my limited knowledge, I can't see any stop to that.
Okay, thank you. Next question, Jade.
Yes, first of all, thank you so much for this very insightful session. I have actually two questions. The first one, do you think if ever we should worry about the future of AI in our lives? Like, I feel that we're walking on a very thin line where we're gonna either fall or like it's gonna be a completely disruptive thing. Should we ever worry about this? And my second question is actually, what should we teach our kids? Because like this is looking like something not like what our parents used to teach us like 10, 20 years ago, and it's not looking like it's going to be the same in not, I wouldn't say 10, 20 years ahead, but I would say like 5 years ahead, like where knowledge is becoming like on demand knowledge, and everybody looks smart and everybody looks that they can write a text from scratch. So what would be your advice to the youngest generation now that they are going into this?
Thank you, Jack. Very good questions. So in terms of future of AI, there has been a lot of disruptive technologies. And again, the books that were written at that time, they sound very similar to today, all sort of alarms. I even heard a story is that when bicycle was invented, there was a lot of things about how can this horse handle with a bicycle, how disruption happens and all that. And then I would say in hindsight, there was a lot of exaggeration. Now, what happens in AI, to be honest with you, like I think there would be some governance and the way we handle it. How long is going to take us to get to AGI? It's hard to know. It's hard to know. But I'm getting an echo.
I think it's from a delay. Okay.
Okay. So if you look at it, I think listening to a number of things, these technologies create a lot of opportunities as well. So going to your second part of the question, what to teach our kids. So I think one is mental toughness, I would say is very important. Second one is how to sort through information becomes a lot important because, in electronics, we have this thing called signal to noise ratio. And the whole idea of what transmission of electronics is based on figuring out what's the signal in a noisy environment and being able to remove the noise and find the signal. And I would say that's the biggest asset that we can teach the kid. And schooling, in a way, is trying to do that, but obviously the method has to be updated. Now, for example, the role of ChatGPT as a custom tutor of understanding. And as I said, it all goes back to where are we? I always go back to this chart. Like, where are we on ChatGPT right now? My guess is we are somewhere here, right at the beginning. So, what sort of exponential is it sitting on? Time would tell. How does it get better? Again, if you look at what we got on the computing, um, what we have in our hand, most corporations didn't have access. For example, if you take iPhone 16, most corporations didn't have access to that much compute in 2005. So that's the power of exponentials. And when we get there, there's a lot of research and how does it change things? How to live with non-organic beings. I would say that's the first time in our life. But that's a very interesting area of research, how to handle it, and what are the ethical issues that show up.
Oh, wonderful. Next question from Krishnan. Krishnan?
Oh, sorry, I had a difficulty in unmuting.
Okay.
Yeah. Hey, so there are, it's a kind of a statement as well as a question in a sense. The first one is, I'm thinking that this is kind of my statement. The AI engines or AI, all ChatGPT, everything will need to be trained, right? So as a public, when we start using those AIs, either it is an Apple Siri or Google Gemini or anything, if we deal with it as a rude kind of person, then that engine may start behaving rude. So, and there is a amount of responsibility with the public that is interacting with those AI systems, that it has to be taught to be kind. Like we may have to treat it like our own kids to bring us our own values. That's one of my thoughts, because they kind of keep learning. We are rude to them, they may be rude to us. And the second is kind of a question I have, is the cultural differences in the society, right? We have drastic cultural, societal differences from West and Oriental cultures, how the society functions, dependency on society, how they treat their authority figures, teachers, parents, and stuff like that. How would this AI will evolve if this AI is common for kind of universally common? How would it be? It will evolve. Is there something mechanism going to be there, or I'm just kind of curious? Is there something there in that?
Mm-hmm. Maybe I didn't understand well the question, but if your question is how AI would emerge, or
Yeah, right now the AI training is all based on either in US or Europe Western thing. We don't have that much of Eastern cultural input to that. And when the whole world starts interacting, how would it evolve? Like, is going to be a common central management, or how kind of what will future look like if Germany used in US, Germany used in somewhere in Eastern Hemisphere?
yeah. So you see, I think maybe as the analogy is today's reaction of what exists, maybe is also would project to future. For example, possibly India would be a big player because of the way the skill set and everything that is exist in India. Today, as you are well aware, US, obviously because of venture capital money and attracting global talent in Silicon Valley is really ahead. Because, when we say US, some people confuse that every state is, like California, or every city is like Silicon Valley area, the Bay Area. So there is unique circumstances or unique ecosystem in US which is successful. Taiwan is very successful. China is like, if I'm sure some of you may have been to Shenzhen. I mean, this is unbelievable work being done there. So how would it evolve? And as the global system get together, I think there's always, with advanced technology, is used on the weapon side a lot. So for example, fake news would go through the roof. Some of the stuff that we have used to, like government of the people, by the people, for the people, it almost becomes meaningless. because of so much interference that can be done with understanding people biases and applying it. And again, there is always a thing that AI tools have biases. It's so obvious because we have. So I think, as Krishnan mentioned, you mentioned, data that was used had biases. So obviously, if you use the data which is biased, your system is biased. So, and no matter where you go globally, there's biases, and those are mirrors. AI is just like a very clear mirror of few billion people looking at themselves through these AI systems. Yeah,
Thank
so
you, Hojjat. We still have four more questions from four people. Do you have time?
yeah, sure, yeah,
Can you stay longer, or you have
yeah,
to go?
absolutely,
You can
yeah.
stay longer. Okay, thank you. Okay. Uh, can I move to the next question because we have a lineup for five more people actually. So next is Vincent.
Hi, thanks for staying on. I'm actually kind of interested in your opinion. With it moving so fast, I don't think we anticipate, like we can't slow down. Do you think there's kind of this collective delusion or resistance in so many industries and professionals are trying to protect their current roles or practices, thinking that we're going to be partnering with AI? Or should we really be focused at this time of anticipating what kind of changes and preparing and transitioning for that rather than kind of defending or thinking that, oh, we're going to have this bridged co-op kind of role? It doesn't really seem to me where a lot of groups that are saying that are in medicine, where I can see it be replacing a number of specific roles would be much more efficacious.
Yeah, that's true. I think it's a wave which is coming, and I don't know if any way to stop it. And any disruptive technology has this impact, especially short term. Like one area that has been picked on is call centers. A lot of application of this child is, oh, it would destroy call centers, or it would enhance it with less resources, much better service. Uh, I think Mark Zuckerberg I forgot, last week said we had never had any reason to open a call center because it's so expensive for us. But with AI, we may be able to afford it. So he was arguing that may create more jobs because he said with AI, we can respond to 2 billion people, questions that are straightforward AI can answer, and then have a call center for more sophisticated questions. The other one that is always picked on is on radiology. Everybody for the last 5, 10 years, oh, they're all gonna disappear. It's all AI systems, and you never know, but they are much more maybe at the end productive. We still have shortage of radiologists, doctors, especially in Canada. So maybe there is other aspect of it that also positive, allows us to do more and then do things better.
Thank you. We could have an AI as a professor as well.
Yeah.
Next question, Eric.
Yes, thank you. And my question is about the two disruptive technology. Do you think that AI and quantum computing will at certain point get together just to save on the energy bill at certain point?
Sure, yeah. So you see, quantum computing, if you guys send me, I will send you a very good paper just published. You see, like I followed quantum for some time. What it is certain problem space is amazing, but it's not really a general purpose that you can do everything. So there is certain problem space that, for example, encryption is one of them, that the solutions on existing computer is not at all comparable to a quantum. But not every problem can be mapped to it. And there is a very good paper on it. I can forward it. That's really the way I see it. Now, with AI application on quantum, honestly, every time you look at disruptive technologies, especially with quantum, lots of things come out of it. So I would say yes, there would be other application that maybe on quantum is even better. but right now it's hard to say.
Okay. Thank you.
Thank you. Next is from Hassan Ham.
Thank you, Professor. Thank you, Hojjat. Great presentation. I just had a quick question in regards to the concept of disruptive technologies. So, with the introduction of phones back in the days, then we also had a form of disruptive technology there because you can connect with your loved ones, but at the same time, the potential of fraud came into play. The same thing can be said about deepfakes. The same thing can be said for social media. Like there's always ethical room to use technology for harm. But it seems that this time around with AI being introduced, there's a lot more attention. I guess my question is why AI specifically this time? Like it feels like this is just another disruptive technology, and in the future there'll be something else to pay attention to. Like, why should we focus this time? Thank you.
Okay. Yeah, that's a very good point. You see, like if you look at GPTs, they're very unique. Like electricity was a GPT, then it went across domains. Sometimes, transistor was a GPT across domains. So that's the reason there is a lot more attention. And, for example, one of the stuff that everybody is worried about is about cyber attack using AI on these, areas that vulnerable. So how do they contain it? How do they stay ahead? Companies, I don't know if you follow Palantir in California, uh, Palantir in California. It's very good to look at that. That's also on the cybersecurity. So there's a lot happening on the cybersecurity for preventive. And then, like new technologies, first, second, third order, only time would tell us where we are headed. That's really the difficult part.
And also right now with generative AI, but when we move to the next phase of physical AI, I think we'll see a lot of change on that. Okay, next question from Sian.
Hi, Professor. I really appreciate your presentation. It's very interesting. I just come with a question in my brain for quite a long time. My personal understanding, or like in my personal studies about ethic, I understand that it's ethic. The framework of ethic is actually it's come from the religious traditions or like a human civil the evolution of human civilization. So and it also the ethic also shaping the norms in our life, like justice, equities, demographics, for example. Yeah, and so my question that is because AI has developed so quickly, and it actually empower a lot of parties make for example Wall Street they can using like a AI to making more monies or some governments they can using AI to enhance their surveillance and the control to their people. So my concern that is who going to represent the rest unrepresented parties the normal peoples. So my question that is in the AI era, who will take over the role of religious or cultural institutions in the past to build our new ethic?
That's right. Yeah. Yeah. So very good, insightful question, and that's, I would say, there is a lot of global forces, if you look at OpenAI was supposed to be a nonprofit. And as you guys have followed, it had a turbulent, past. And I think recently they may have said, oh, we want to keep it nonprofit. So the idea was that how do you make it something that have access to everybody? Crypto original thing was that some technology that everybody can use. For example, some people who don't have access to banking can use these cryptocurrencies to be able to do it. Ownership, the places that they didn't have uh, regulations like Canada to document that this house is mine. They had, crypto to help them to show ownership of stuff. So all these happens, but fundamentally, so far there is always winners comes out of this. History has been like this. The winners come out of it, and they are the controlling forces. So right now, as you can see, I would say if you look down the road, maybe 10 years after that, God knows, but 10 years, maybe US, China, India, there would be these three forces that, because of their expertise, talent space, amount of regulations they are putting in place, and basically brain power, they may be ahead, in these stuff. Now, how much the regulations and all that come from, on nuclear, we could have blown each other into pieces, isn't it? And nothing happened. So there was, Russia had a lot, US had a lot, then China has a lot, Israel has everybody has nuclear power now, nuclear weapons, sorry. And we could actually, in a couple of buttons, everybody is gone. So nothing has happened. So there has been some governance, there has been cases that we agreed, collaborate, and make sure those is controlled. And would that happen in AI? I'm pretty sure. It's just, we have always got there eventually. And I
Yeah.
think this is another case.
And also next week we have another guest lecture from United Nations. So the team that I was invited for me last year to work, so they will come in to talk especially with the global level governance of AI. I can send you the link to Hojjat if you're free to attend.
Sure, yeah.
Yeah,
Thank you.
thank you. Last question, Abdulaziz.
Hello, you hear me, guys?
Yes.
Yeah, we have a little of echo. Give me a second. You know,
We get a lot of echo, Abdul.
yeah.
Oh, the other option for you, can you type your question in the chat?
Yep. Go ahead.
Yeah, you can
No,
try.
you good?
Good. Try one more time.
Okay, I gonna stop the speaker, but I don't gonna hear you, so I just gonna
Okay.
ask my question, but I don't gonna hear you if you say something. Okay, like that,
Okay.
it's gonna
Can you,
cut the.
or the other one is can you type your question in the chat so I can read it for
I
Hojjat.
mean, now you have an echo or no? Just shake your head. I don't hear
Okay,
anything.
this is better. This is now.
Okay,
This
you're
is
good?
good. Good.
Okay, so you still have an echo?
No, that's good. It's good. Go ahead.
Okay. Yeah, it's not a question. I just want to say that I witnessed what he said about, let's say, new disruptive technology and the anti-technology. It's already happening with ChatGPT because I'm working at U Ottawa, and we have problem with the cheating. You not really cheating, but students are using ChatGPT or other AI, and it's not super great. So we have an anti like software which is called responsive responders who's detecting the AI, and already we have an antidote. I mean, they have like some tools to make sure they pass those detector. I mean, it's already starting that kind of controlling a war between the technology and how to control it. It's already starting. Yeah, that was just a comment. I'm not asking any question.
Okay.
I'm back to you.
Okay. Thank you.
Thank you.
Would you like to respond to that?
True. Yeah. I just quickly, definitely it's true. If you look back, calculator was like that. There was so much fuss that you can bring a calculator to an exam. And now ChatGPT maybe is the new calculator. And people get used to it in a few years, everybody forgets about it. And the way I would say to think about it is I think the digital me, that's one. The other part is Copilot is a good name. I know Microsoft uses it, but it's a good way to put it. For now, it's a Copilot. So sometimes it can be autopilot, but in a more effective way to use it as a Copilot. It's much more effective. Thank you, guys. Thank you very much for your time. Thank you, Dr. Chanarang.
Thank you